So now let's talk about adding and subtracting rational expressions when our denominators are not the same, when we have unlike or uncommon denominators. So like in the example that we can see here, my denominators do not perfectly match. One denominator is 7a, the other one is 6a. So I can't perform the normal addition like we would, just adding across the numerator. So how do we approach this problem? Well, step one is we need to find what we call LCD, least common denominator, of each of our fractional or rational expressions. And then we need to make sure that we rewrite those rational expressions so that they have an equivalent denominator for the least common denominator that we found in step one. So looking at our denominators, 7a and 6a, we want to see what factors they have. So here 7a is already in its own factored form. 6a I could think of as 2 times 3 times a. Either way, we don't really have much in common. They do have the value of a in common, so our least common denominator will have an a in it. It needs the value of 7, and it also needs the value of 6 or 2 times 3. So we're going to multiply all those factors, any factors that either denominator has, all together, and those are going to be our least common denominator. So 6 times 7 is going to yield 42a. So I need my fractions to have this common denominator of 42a. So taking each of those rational expressions, I'm going to rewrite them. And I'm going to go ahead and multiply by whatever factor is missing that I need to include to create that 48a. So looking at my first fraction, I have the factor of 7 and I have the factor of a. What's missing to create my least common denominator is a factor of 6. So whatever factor is missing, you want to multiply by the top and the bottom of that fraction. The reason being is I don't want to change the value of whatever my expression is. I just want it to have that additional factor. So if you multiply by any number over itself, that's just like multiplying by 1, and multiplying by 1 doesn't actually change the value of whatever you wrote down. Similarly, on the second fraction, I'm missing the factor of 7. I have the 6, I have the a, I need that extra factor of 7 so that way it matches my least common denominator. So now we're going to perform that multiplication and write out those new fractions in their form so that way we can go ahead and do the addition. So 15 times 6 is going to give me 90 over the 42a. 8 times 7, it gets me 56 over the 42a. So now I've went ahead and rewrote them in that equivalent form that has the least common denominator. And the operation that we were doing was plus, so now I'm going to write that with a plus sign. And I can go ahead and perform the addition now that they have a common denominator. So their denominator is that 42a, and I can go ahead and add up 90 plus 56, which is going to give me 146. And then the last step, just like any time we've been dealing with fractions, we want to write our results in its simplest form. So if there's any common denominators that we can divide out, we want to go ahead and do that. So this one, because my numbers are pretty large, it may be hard to identify what the greatest common denominator might be. So if you're anything like me, you may only recognize the smaller factors, and that's okay. You can do multiple divisions to get your common factors pulled out. So here I recognize that these are both even numbers, so I could go ahead and divide each of them by 2. When I do that, I get 73 after dividing 146 by 2. And 42 divided by 2 gives me 21. It looks like I might be able to divide by 3. Let me try that. 73 divided by 3. Nope, that doesn't work out. I know 21 is 7 times 3, so let's see if 73 divides evenly into 7. That doesn't work either. So there aren't any other factors that I see that could be divided out. So this would be my final answer in simplest form. So let's try this a little bit more and some more complex expressions. So looking at example A here, again, we don't have a common denominator, so we need to make a common denominator. So comparing my two fractions, I can see they do have an x in common. However, my second fraction has a 2 and an extra factor of x inside of it that the first one doesn't. So what I need to do is multiply the first fraction by those missing factors, the 2 and that extra factor of x. My second fraction already has the value of x inside. There's any extra factors from the first fraction that the second fraction doesn't have. So I don't really have to do anything to the second fraction. I just need to change the denominator of my first fraction. So multiplying 2x times 3 gets me 6x. The denominator will be that new 2x squared that we were hoping to get as a common denominator. And because now we have that common denominator, we can go ahead and perform the addition. So 6x needs to combine with 5 for my numerator. Here, again, we want to simplify our fraction if we could. I can't do anything in this case, though, because the only factor that might have been able to come out is a factor of 2. And although 6 has a factor of 2, 5 doesn't. So I can't pull out a factor of 2 from my 5. So this is as simple as we can make our first problem here. For the second example, this one it may be tricky to identify what the common factors would need to be. So a good trick that I like to use is to factor my denominators completely to start, just so that can help me identify what factors they may have in common, what factors they might not have in common. So x plus 4 is already as factored as he can be. 3x plus 12, though, I could pull out that common factor of 3, and that helps reveal for me that the two fractions do have x plus 4 in common. My first fraction is just missing that extra factor of 3. So really, to get a common denominator, I just need to multiply the first fraction by 3. So 3 times 8 gets me 24. And I'm just going to leave it in the factored form. And the reason for that is we kind of have a sense whether or not we might be able to simplify fractions based off of the factoring. So if I leave my denominators in the factored form, then it just makes that last step of identifying, do I have my fraction in simplest form or my answer in simplest form, a little bit easier. So it's still that same 3x plus 12, but I'm just writing it in that factored form with the 3 being pulled out. So now that we have a common denominator, I can go ahead and subtract. 24 minus 3 is 21 for my numerator. And here, having that 3 factored out helps me because I know 21 does have a factor of 3. It is 3 times 7. So I can cancel out a value of 3 for my numerator and denominator, which gives me my simplified answer of 7 over x plus 4. Our next problem might look like it's not the same sort of setup as what we've seen previously because we don't see two fractions. However, if you're doing addition and subtraction and even one of our values is a fraction, then we essentially are still in that method where we're going to need a common denominator to combine our two numbers. So here, even though 3 isn't a fraction, I'm going to go ahead and make him a fraction by putting him over 1 and then going through that same common denominator process. So the common denominator is going to be essentially our denominator that we had in our first fraction, 2x minus 3. And to get that denominator into our second number, we're going to go ahead and multiply it over itself. So the result here, my first fraction doesn't need to change at all. My second fraction, though, to get a common denominator, I need to multiply by that 2x minus 3. And so to do that, I'm going to go ahead and distribute my 3 to both terms. So 3 times the 2 gets me 6x, and 3 times 3 will yield a negative 9. So I've rewritten my 3 essentially as having that same common denominator, so we can perform our subtraction. Now, anytime you're doing an operation with subtraction or involving a negative, you always want to be real careful because there may be some change of signs that we have to keep track of, and this is a great example of that. So here, when I'm subtracting, I'm going to be subtracting both of my terms, which means my negative is essentially like distributing to each of those terms. So I'm going to have 7 minus 6x, but then my minus needs to also apply to the negative 9. So minus negative 9 will turn into plus 9. So it's a good habit to just kind of get in the practice of treating anything involving subtraction or negatives very, very carefully and just keeping your eyes peeled for those potential double negatives or change of sign. So I can go ahead and combine like terms here. 7 and 9 are like terms. Those will add up to 16. And negative 6x can't combine with anything else, so he's left alone. Now here, again, we want to simplify, and if we're not sure whether or not we can simplify, the safe bet is to go ahead and factor to see if there ends up revealing a common factor. So 16 and 6 do share a factor of 2 that I can go ahead and pull out, and that would leave me with 3x. I pulled out -2 actually, just to kind of hopefully get it to match. So I got 3x minus 8, which does not actually match the 2x minus 3 in the bottom. So what you can do is just go back a step to before we factored it, and then circle that as your final answer. Our next example is going to be a little bit more complicated. Now we got some trinomials happening, and our strategy is the same. I want to go ahead and completely factor each of my denominators so I can see if there's any common factors that they share, and any uncommon factors we can go ahead and multiply to get those least common denominators. So first what I'm going to do is pull out, there's a common factor of 4 in my trinomial, leaving n minus 3n, or n squared rather, minus 3n plus 2. And I still want to factor it further because it's a trinomial. I can factor it into 2 binomials. And my 2 factors would be n minus 2 and n minus 1. My second fraction, I have a common factor of 3n. Factoring that out leaves me with n minus 2. So we can see what they have in common is the n minus 2. And so I need to multiply whatever factors the fraction doesn't share on each side. So looking at my left-hand fraction, what I'm missing is a 3 and an n. So I need to multiply 3n over 3n. And my second fraction, what's missing is the 4 and the factor of n minus 1. So I need to include both of those on my second fraction. So this one is pretty complicated just because we have so many factors within our denominators for these expressions. So here multiplying 5 times 3 will give me 15n. And here I can multiply the 3 and the 4, that's going to get me 12. And I could distribute that 12 through to my n minus 1. So 12 minus n. And then 12 times the -1 gets me -12. And if you notice again here, I'm just leaving my factors in that factored form. I don't want to re-multiply those out because I want to be able to identify whether or not I can simplify my final result, which means I need it kind of in its factored form anyway. Oops, I forgot an extra factor of 3 there. So they do have a common denominator. They share 4, a 3, the factor of n, the factor of n minus 2, and the factor of n minus 1. And now I can perform that subtraction. So again, being very careful because I have negatives involved. The negative needs to go to the 12n and also to my -12, which will yield a change of signs. So I can combine the like terms of 15n and 12n. That'll leave me with 3n plus 12 for my numerator. And then I would want to see if I have any common factors with my denominator. That way I could simplify my results. And here we actually do have the common factor of 3 that we could pull out, leaving n plus 4 in my numerator. And then here I'll show that 3 canceling with our 3 in the denominator. So that value of 3 can cancel. And so my final answer would be n plus 4 in my numerator and 4n times n minus 2 times n minus 1 in my denominator. And although we may be tempted to multiply out that denominator, usually when you have a lot of factors like we have here, the mathematical kind of convention is to leave it in that factored form. That remultiplying it would just be too much effort just to have a multiplied out denominator.